Have you ever sent a secret note to a friend? Maybe you wrote it in a special code that only the two of you could understand. Now, what if I told you that you do this every single day, dozens or even hundreds of times, without even thinking about it? Think about your daily life. You send a text message. You log into a video game. Maybe you buy something online with your parents. Help. In all these moments, you are sending information across a vast public network we call the internet. Your messages, passwords, and data travel from your device, through the air, and across cables to reach their destination. Imagine sending a postcard. Anyone who handles it along the way can read what's written on it. Early on, the internet was a bit like that. Your digital information was like an open postcard for anyone to see. This created a huge problem. How can we share private thoughts, secure passwords, or financial information if anyone could be listening in? The world needed a digital envelope, a way to seal our information so that it could only be opened by the person it was meant for. This is the challenge that engineers and mathematicians had to solve. How do you make a message secret, even if it has to travel through a public space? The answer comes from an ancient art, updated for the digital age. It's called cryptography. Cryptography is the science of secret communication. Its goal is to make a message unreadable to everyone except the intended recipient. It's like turning a clear message into a jumbled puzzle and only giving the solution to your friend. In the world of cryptography, your original readable message is called plain text. It's just plain, normal text. When you use a secret code to scramble that message, the scrambled version is called ciphertext. It looks like complete nonsense. The process of turning plain text into ciphertext is called encryption. And the process of turning it back so it can be read is called decryption. To understand this, let's look at one of the oldest codes in history, used by the Roman general Julius Caesar almost 2,000 years ago. It's called the Caesar cipher, and it's beautifully simple. All you do is pick a secret number, which we'll call the key. Let's pick the number 3. Now, to encrypt your message, you just shift every letter forward by 3 places in the alphabet. So the letter A becomes D, B becomes E, and C becomes F. If your secret message was the word hello, you would change it letter by letter. H shifts 3 places to become K. E becomes H. L becomes O. And O becomes R. Your plaintext hello has been encrypted into the ciphertext KHOOR. To anyone else, it just looks like a random jumble of letters. But your friend who knows the secret key is 3 can decrypt it. They just shift every letter back by 3 places, and the original message magically reappears. This is the fundamental idea of cryptography. A shared secret, the key, allows 2 people to communicate privately, even when others can see their messages. Of course, a simple Caesar cipher is very easy to crack. There are only 25 possible keys you could use for the English alphabet. You could just try them all until the message makes sense. This is where modern technology comes in. The computer in your phone or laptop does the exact same thing as the Caesar cipher, but on an unbelievably more complex level. Instead of just shifting letters, modern encryption uses incredibly complicated mathematical formulas to scramble your data. And the keys are not small numbers, like 3. They are enormous numbers, often hundreds of digits long. These keys are so long that even the fastest supercomputers in the world would need trillions of years to try and guess them all. It's the difference between locking a diary with a simple toy padlock and securing a bank vault with a door that's 10 feet thick and has a million possible combinations. So when you see that little padlock icon in the address bar of your web browser, that's what's happening. Your browser and the website have secretly agreed on a massive, complex key. They are using that key to encrypt all the information sent between them, like your password or credit card number, turning it into unreadable ciphertext. Any hacker who tries to intercept the message will only see a meaningless stream of jumbled data. Only the website, with its matching secret key, can decrypt the information and understand it. This is the big insight. Cryptography isn't just about cool spy codes. It is the invisible shield that protects our entire digital world. It's the silent guardian of your private conversations, your online accounts, and the global financial system. Every time you connect to a secure Wi-Fi network, send a private message, or access your online bank account, you are using cryptography. It's an incredible partnership between mathematics and computer science, creating a bubble of trust and privacy in the wide-open space of the internet. This amazing technology is built on a very simple and very human idea: the power of a shared secret. Cryptography works constantly in the background, a hidden language that our devices speak to keep our information safe. It's a perfect example of how a very old idea, making secret codes, can combine with modern math and engineering to build the world we live in today. So the next time you press send, remember the secret language of codes, working silently to turn your private words into a secure whisper across the globe.